Right. So today let us begin a new chapter, that is on system design. So the first question about system design is where does system design begin after system analysis? So we have been discussing the various aspects of system analysis, particularly decision analysis that we have covered just before this. Now, what is the boundary? When do we know that analysis is over and then we should begin design? Then when we begin design, what are the broad considerations that we must make, right? What are the broad things? Basically three things. One is user procedure, the design of modules and the database design. These are the three broad considerations. Then what is modularity? Because one of the major component of system design is dividing the whole thing into small modules. Why? Because I have told you before that it is not possible to develop the entire software by a single person. You need to bring into it productivity by taking a number of people. Whenever we have a number of people, if you are not able to divide the whole software into modules, you cannot achieve anything. There will be only chaos and the productivity will be very, very low. In this regard, there are two important concepts which we shall discuss in detail, that is coupling and cohesion, right. Basically the idea of coupling and cohesion is that when we decide the modules, how the modules are coupled with one another, right. So, we have one module, we have another module, how should they be joined? Should it be strong or weak? And similarly cohesion or the strength, that is within a module there are substructures, how are these substructures connected to one another? Should it be strong, should it be weak, or what are the different considerations? Now, when we have different modules, there is a particular thing called a structure chart. The basic idea of structure chart is it connects the module and basically shows the hierarchy of the modules. How are the modules are connected to one another? So, with again the coupling and cohesion comes here, the concept of coupling and cohesion. The structure chart is it is like the data flow diagram basically shows how the data flows from one source to another and what transformation it undergoes. Similarly, the structure chart shows what are the different modules, how are they connected to one another. So, it is a very important concept, structure chart, and let us see in the course of system design how we achieve all these step by step. Now, before going to design, let us go back to analysis once again and very quickly let us review the analysis process. The structured analysis begins with study and model the current system using data flow diagram. This is called the physical model, right. So, first what did we do? We try to, I have told you time and again that it is not easy to model the current system. Many a time in the name of current system we model a proposed system or a system which is in our mind. So, this is the first job and that is known as the physical model. Then we have to derive the logical model. Now, naturally the logical model need not be one, there may be a number of logical models which may be derived from the physical model. Now, naturally the whatever logical model we may choose, you have to show the data flows and what transformation it undergoes in terms of DFD again. Then establish human machine boundary, manual versus automated activities. As I said before, there are going to be a number of alternatives, several alternatives, code them using data flow diagrams. Say for example, the simple check processing system we have seen, there could be number of alternatives. right, and depending on the number of alternatives, the manual or automated activities could be different. Then perform cost benefit analysis for each option. Suppose finally you choose some 2-3 options, you have to find out their costs and the related benefits out of this whatever we have already obtained. Now select the best option. So when we have several options, the option which is best suited to us, maybe with regard to cost or other considerations, that is going to be our best option. Again, who will select this? Not the developer, but the client or the management or the company who is giving you this job. Ask the management about the hardware, budget and time requirements. You have chosen the option, naturally you have to have resources. Without resource you cannot carry out the job. So you require hardware, budget and time, 3 important things. Without hardware you cannot develop, without budget expenditure cannot be made, and without time nothing can be done. But most often the time is usually yesterday. Most people, they give the job and they want it yesterday. There is no time. I mean, suppose you ask when you want the software to be developed, they say yesterday, which means the time is 0, there is no time, you will give it now, right. So there is no time, but again this no time concept does more harm than it does any good, right. So what usually happens, you try to develop the system in a very short time without much thinking, without documentation, without proper modularization, and the end result is a package or a software which cannot be run. So you redevelop, fall into the loop. We have discussed this in the project management already. Now package the specifications in a structured specification document with data flow diagrams for system functions, data dictionaries for data flows or stores, process specifications in terms of the decisions or whatever, input output documents, and requirements of this we have not discussed much, security, control and conversion. Security, we all know, whenever we have a system, the system must have a good security. Very important consideration, definitely the security of hardware, security of software and security of the data. All 3 are very important. Security of hardware may not be, is difficult, definitely very difficult. There should not be any wrong activity done on the hardware. Similarly the software, proper care must be taken, but much more important is the security of data. Think of a bank whose data is due to whatever reason tampered. Naturally it may cost much more money than probably that of the hardware or the software. Very important aspect, security itself is a very big consideration, and we will discuss maybe on some other day. The control, usually what it means is that whenever some operation is done on a given software, this operation, is it done by an authenticated person? So these are actually control issues. Say for example, you have got a B grade in a subject, but actually you should be getting an A, alright. You have discussed with the teacher and you have, okay fine, you have got an A. What should be the procedure? Should you go to the establishment section and open a computer and change it to A? Suppose this is allowed, suppose a student is allowed to change his own grade in good faith. A time may come when a particular student who is not very morally correct may change his own grade without the permission of anybody else, alright. So you see, sometimes we allow, sometimes we say okay, this is the computer, you do it in good faith, fine, but whenever this is done, you must know the control of the system is not being done properly. It should not be done, right. A situation may arise when the whole system or the process cannot be brought back to normalcy. This is why it is necessary that every activity that is to be performed on the software or the package or the application system must be properly controlled, right. Who does what is the operation, what is the procedure, where does it go, everything must be properly documented and it should be followed. Think of something like payroll, very important thing. People are earning incentive, people are earning increments. Who will enter incentives and increments? At what time? Alright. See, just because, that is why, let me give an example. What is being done while entering your marks into the computer? Two people parallelly enters it. It is not that your marks is entered by a single clerk. It is entered by two clerks simultaneously from two different computers, alright, and they are not allowed to go back. Suppose a given clerk enters your grade, he cannot go back to your grade and change it again. If he has already entered your grade, that is the end of it. He cannot go back to your grade and change it, even if he has made a mistake, alright. Then what is done? These two separately entered marks by two different clerks are compared, alright. What usually happens, suppose a given clerk has made a mistake, the other clerk will usually not do the same mistake. Although there is a small probability, usually less than 1%, that both the clerks makes the same mistake. There is a small percentage of that chance is there. So, it is necessary to check overall, but nevertheless this process is not too bad and many places this is followed, right, double entry, and the clerks are not allowed to go back to the data that they have already entered. Who should compare? Someone who is higher up than both the clerks. So, this way you can build into the system certain amount of control, in the sense that if someone wants to do something wrong to the system, it should not be possible by a single person, alright. So, these are part and parcel of any system, so that we can have a relatively error free or corruption free system, right. This is important. Some other day we will discuss these things in some detail. Definitely conversion, you all know, is another big thing, that is whenever you develop a system, that is not the end of the system, you have to maintain it, and one of the major portion of maintenance is the change of the hardware. For example, if you think of our IIT payroll system, the IIT payroll system in the very old days was in unit record system, punch cards and all those things, right. Now, from punch cards then it came to one very old Horizon computers, right. Now, in the process the computers keeps on changing. From Horizon to Horizon, people went to HP 9000 system. Now, when they went to HP 9000 system, what happens? HP 9000 and Horizon do not run the same version of, let us say, C, alright. So, if it was written in C or COBOL, then you may have to change some portion of the software, right. These are called conversion. So, today there is a word which is called portability. What is portability? Portability is when you move your application from one system to another, one computer system to another computer system, you should see to it that the same software runs. That means, as far as possible, do not use some commands which are computer system specific, alright. Suppose some commands in C or some commands in Java or any other database language does not run in a given run on only given computer, not on all computers, do not use it. Right? These are called portability considerations. These are other issues. Let us come back to what we are discussing. So, this is about structured analysis. So, our question that where does system analysis begin or system design begin? Again let me tell you, there are two kinds of system design. One is our structured system design and the second is our object oriented system design. So, at the point we are focusing more into the structured system design, not on the object oriented system design. But let me tell you, whether we discuss or not, the object oriented system design and the our structured system design has got lot of things in common. So, basically the principles what we are discussing here will be broadly true with some small changes, right, and the changes are not too much, in the sense the basic concept, the broad idea will be similar. Now, this is our diagram to show the design process. Basically the design has got three major component. One is that, see, as I said before, there will be automated and manual components and we have to identify the subsystems, right. So, for the automated subsystems that we are calling the computer subsystems, we have to develop process specifications and then we have to develop structure charts. What is process specifications? In terms of maybe structured English, decision tree, decision tables, etc. And as I told you, structure chart is a diagram which shows hierarchically the interconnections between the modules. Fine. On the other side, the manual system. For the manual system, you have to design the user procedures. What are user procedures? What a user is supposed to do, what data he has to enter, what output he has to get, and after getting this output, what he is supposed to do, how does he prepare the input, what processing he carries out. If you have everything automated, fine, everything comes under computer subsystem, but even if there is a single manual intervention, it has to be designed in detail. What the person has to do, what programs he has to run, which buttons to press. So, as I said, there are two manuals, user manual and the operations manual. Operations manual is for the operator, which buttons to press, something will come, then maybe press P to print, etc., etc. This is called operations manual. The user's manual on the other side, how to prepare the input, how to interpret the input document, how to enter the data, what validation checks will be done, what to do when the computer shows certain messages, maybe error messages, and then how to interpret the output, where the output is to be sent, what are the background processes that are to be done. For example, in payroll, you may have to collect the input data with regard to attendance, right. You might have designed a system where computers are given to the security sections. So, what the security people are supposed to do? What is the procedure they have to follow? As the people are entering the office, they should maybe in their palm top or terminals or wherever else, they have to enter the data that the given person has come in at a given point of time. So, all these are part of user procedures. So, as I said, two manuals, user manual and the operations manual. Operations manual, basically what to be done in computer, like press P for print, press this button to run this particular program, etc., etc. You do not need any application knowledge, you are just an operator, right. So, that is called operations manual. The user manual on the other side, all the user procedure, something to do with the business function. On the other side, we have the database design, is a topic in itself, and as you see, you may develop the structure chart, but when you actually go into the module in detail, at that time you require both user procedure and the database design. Because see, end of the day you have to do coding and testing. Coding means developing actual programs, right. So, when you develop actual program, you have to have how the program interfaces with the user, that is the inputs and outputs, and the database. So, both these must be available, otherwise actual program cannot be developed. You can develop a structured English statement, because even at the stage of structured English, it may show the processes, it may show the inputs, outputs, etc., but it can keep things unclear. It need not very clearly specify where from the input is coming. But if you have to write an actual program in C or Java or whatever language, you have to actually know the database, you have to know the user procedures. In between we have the package design. The basic idea is that when you have designed the modules, it may be some modules you may have to take together, right. So, how you take those modules together or differently, because that will ultimately determine the testing, fine. So, that is the part of the package design. Now, very quickly let us overview some of the important things about system design. The first and foremost activity is the broad system design. Three components are there: manual subsystems, basically user procedure design, two manuals, operations manual and the user manual, automated subsystems, process specifications, structure charts, then database design. There are lots of things in database design, we will discuss it in great detail next week. Then detailed module design and package design, and which will ultimately lead to coding and testing, fine. So, these are our system design activity. Now, after we have understood the basic difference or transition from system analysis to system design, let us move over to module design, right. That what are the basic considerations, or basically see, the given idea is we have a data flow diagram, how to translate the data flow diagram to the modules. So, these I will not discuss today, it will be in our next class, how to develop structure chart, but today I will basically discuss about the concepts of modularization. Now, it is important to design modules basically for three reasons. What are the three reasons? The first one, it allows assignment of tasks to different analysts and programmers, because a big job, for example, I have told about SPSS software which may require thousands of man years. We cannot develop it for 1000 years, therefore, at least 1000 people should work for 1 year, right. So, if 1000 people have to work, you have to divide the job into 1000 parts. If you cannot do it, then 1000 people will not be able to work, fine. So, that is the first thing, allows assignment of tasks to different analysts and programmers. It makes possible the development of software in independent small sections. This independent word is important here. The sections should be independent, because if they are dependent, see what may happen, suppose you only are developing the entire software, and because you are a very intelligent person, you have been able to divide the software into very complicated modules with lot of interconnections between them, so that understanding one module requires the understanding of all other modules. So, see, essentially, therefore, you have to know about the complete system perfectly. Think about yourself, suppose tomorrow you join a software company and suddenly you have been asked to develop or be a part of a team which is working on some complicated aspects of financial management, say particularly to the assets management side. Now naturally, because of your background in engineering, you do not know much of financial management, forget about assets management, which may be even further, right. So you cannot, even if you wish, however intelligent you might be, you cannot understand the complete financial management package in a small time. It is not possible, right. And please understand, when you are a student, your job is basically to learn. When you are joining a company, your job is not to learn, your job is to deliver, is to develop, is to do something. Here you are evaluated. When we set question papers, evaluate you, we basically evaluate you to know how much you learn, how much you know, basically on the basis of your knowledge. But in industry, you will be evaluated not by what you know or what you have learned, but by what you have delivered, what you have done, alright. So you see, these are two different things, but interconnected. If you do not know, you cannot do, alright. Sometimes to do something, you have to know something more. The problem is, there is no time to know something more, because you have lot of things to do and you have to do in quick time. So these are the dilemma that the software people are continuously facing, because I think you know, software is a product which is being obsolete at the fastest possible rate, right. So if you know something about not really much of system analysis and design, this is more or less not changing so much at that first rate, but programming, knowledge of programming, knowledge of languages, DBMS packages, networking knowledges, these are changing very fast. In 3 to 5 years time, whatever you know has changed, you are completely obsolete, fine. So you have to learn quickly, alright. So but there is no time, you have to do work in no time. So that is why modularization is all the more important, so that you are given a small package, you are given a small module, all you have to do is understand the inputs, understand the outputs, logic is also given to you, you have to simply write the code. Sometimes another fundamental question comes that are we then turning human being into automations? These are another problem really. So you see, if that is all you do, specs are given, inputs, outputs and process all, and all you do is just convert it, then why intelligent people are required? These are very serious questions. In fact, suppose you are the owner of the company, and if this is the job, why should you pay more for this job? Okay, agreed, you have taken an intelligent person who can do job very quickly, and productivity of software people can vary tremendously, right. A very good software person can be even 20 times more productive than a bad software person. So considering this, you have taken an intelligent person who can do these things very quickly, and after 1 or 2 years training, he is really very good, he is doing it at a very fast rate, fine. Now the same person after 10 years, will he be 10 times or at least 4-5 times better? Doubtful, because the job does not require much intelligence. So if you are good after 1 or 2 years, you can be little better, not 4-5 times better, but in 10 years time you should be given 4-5 times more salary. Yes or no? You must expect in 10 years time, at least forget 4-5, at least 2-3 times more you must get. Now tell me, if you are a software company owner, why should you pay a person 2-3 times more for more or less the same job? This is where the dilemma is. The answer to this question is, do not utilize that person for program writing. Use him for better jobs. Alright. So, this is why you should not remain a programmer. If you are very good, you should write program for some time. It gives you experience, important, definitely yes, but do not remain a programmer. Be an analyst. Alright. Be an analyst, be a quality expert, or if you think you are not really cut out for this, go to administration. Alright, be a regional manager or go to marketing, because no company can stay without marketing. Somebody has to bring the job. You can do the job only after someone has brought the job. If the job is not there, what will you do? So, very important activity is marketing. So, these are the things. If you are going into the application software line, see, please remember, these are dilemma in the application software, not so much in system software, because system software job is challenging in itself, right. If you have to decode Windows, then even if you are a programmer, you are doing a highly skilled job. Someone cannot write every possible algorithm, or everyone cannot understand every possible algorithm that is inside an operating system. But in application software, this is not true. The writing code is not that not that difficult. Anybody can do it without much knowledge, because of modularization, right. So, these are the things. You have to be an analyst, or you have to be in administration, or in marketing, or in specialized areas like quality, etc., configuration management, securities, things like that, right. The problem is, maximum number of people required are in programming, alright. Including all these together, the requirement of people is not as high. Suppose you require 5,000 programmers, you do not need 5,000 analysts. For 5,000 programmers, you may require 50 analysts, alright, and you do not need so many marketing people and administrators and quality experts and other kind of people. So, somewhere rationalization has to come in. You have to accept some people who could not do it has to remain a programmer, because you see, this is the flip side of the thing, alright. So, one should be aware of industry that, see, I am a programmer, I should be really good to become an analyst, I should be really good to even become an administrator. Definitely being an administrator is not easy, or go into marketing, or go into specialized areas. But if I cannot do any of this, I will remain programmer and continue to accept low salary, because you cannot expect that high a jump if you just remain a programmer, right. So, these are some of the important issues which are connected to it, right. And but at the same time, you all will agree that if you do not modularize, you see, in the earlier days what used to happen, software was considered an art, right. Because it was considered an art, naturally it was used to be 1 or 2 people job, right. 1 or 2 people using their mind, they used to bring up like a magic, a solution to something which was earlier done manually. So, people used to get lot of satisfaction out of their job, because there were very few people, the software developed was simple and not much of complications was there. But that thing has changed in today's world, right. You have to develop software, large software in small time with using lot of people. So, you have to make it mechanical, and this is the job of analysts, that bring it down to such a level that even ordinary people can do it. In fact, beyond modularization, nowadays there are a number of code generators and case tools, right. What are code generators? Code generators are, if you give the inputs, it automatically generates. You do not have to write a C program or a Java program or C++ or any other. All you have to do is feed the basic details into the code generator. The code generator will generate the code. I have seen a few code generators. Unfortunately, the code generators generate huge amount of code. Suppose what could have been done in 80 lines, the code generator will probably generate 800 lines, because they do it in a generalized manner. Everything is there, whatever is required they put, right. The case tools on the other side, they are actually computer aided software engineering tools. They are basically tools to improve productivity. So, maybe there are pre-specified libraries and to do lot of important activities, right. So, this has made even more simpler the task of coding. So, day by day what is happening, the coding task is becoming easier and easier, but naturally that other side of it, that is the analyst's job, you cannot replace it by computer or anything else. So, somebody has to go to the field, understand the requirements, put it together, bring it, synthesize it, but definitely what is happening, body of knowledge is increasing, and slowly the business functions are becoming more and more integrated worldwide. This is why we today see systems like supply chain management, we see systems like ERP, enterprise resource planning, those kind of integrated systems are coming, and more or less good companies are following standardized procedures rather than every company trying to use their own procedure. This also to some extent makes the analyst job slightly easier, but I will not say easier, because reality is reality. You cannot, even if someone says that we follow ERP, in practice you will see there are lots and lots of deviations. You have to understand it, and understanding will be all the more difficult because a complicated software is now involved. You see, not earlier it was everything from ground zero, you can use your first principle. Today you cannot use your first principle, you have to first understand what is ERP, what is the ERP procedure, and then understand the deviations, right. So, these are some of the important considerations. Now, modularization leads to least disruption during system maintenance, very important. If the structure is very clear, maintainability improves. So, three important considerations: one is assignment of tasks is easy, second, development of software is easy, maintenance of software is easy. So, this is why you must divide the software into modules. Now, the process of modularization is to be satisficed rather than optimized. See, satisficing and optimizing, what is the difference? Optimizing means the best, right. So, it means best in the sense in a mathematical term. That means, if you want to maximize, this gives you the maximum, that module connection that gives you the maximum. Satisficing on the other side is may not be maximum, may be maximum as well, but is a solution which is obtained earliest by using heuristics, trial and error method, which apparently satisfies what we intend to do. Unfortunately, there is no optimization really possible in software, really very difficult. Some attempt has been made, it is not that no attempt has been made in software engineering, particularly with operating system, right. So, if you study computer science, you will find that they wanted to code the specifications in terms of formal specifications, alright. So, they want to mathematically code the specifications, but as you know, this is possible only when the problem is algorithmic, mathematical, alright. Suppose you want to find out something like say a solution to the Bessel functions, right. You have a problem involving Bessel functions, you have to have a special algorithm to solve that particular problem. Then probably the specifications could be formed in terms of mathematics. But if your solution is how to improve the payroll in a situation where people may suddenly go on strike, or there are hundreds of incentives and increment systems, what mathematics is possible? Alright, tomorrow central government may issue an ordinance and the entire structure may change. Mathematics is not possible, right. So, in application software you have to go for what is known as satisficing rather than optimizing, right. So, let me show yes, just last slide, let me show the last slide of today, that is finally this is how we can define a module. A module is a group of statements having a single name and treated as a unit, that can be called a definition of a module, right. Then there are two important concepts, one is cohesion. Cohesion is how well the activities within a single module relate to one another. The another name to cohesion is strength, strength or cohesion, how well the activities within a single module relate to one another. Similarly, the separate modules should be relatively independent, that is they should be loosely coupled, and these facilitates development, maintenance by teams, reduces chances of unintended ripple effects on other modules when changes are made to a module. See, basic idea here is that we have different modules, right, and suppose you make a suppose they are not loosely coupled, what will happen? If there is some change in one module, this will affect another module, alright. So, to understand a given module, you have to understand not only that module, but also many other modules. You see, you take a given module, this module may be connected to 5 other modules, okay. Now, suppose some change is made in 5 other modules, then the behavior of this module will also change. So, you see, with apparently the same input, you are getting different outputs, not because of the module itself, but because of some changes in some other modules. So, these are known as ripple effects, or these are known as coupling related problems, alright. So, these coupling and cohesion we shall discuss in our next class, fine. So, stop here.